Hello, Unit Circle Trig 5. We're going to think more about thinking in radians. In the last video, I described how to think about converting angles from degrees into radians by thinking about pi as an actual rotation, a half turn. I'm going to continue with a couple more issues related to that. Really, one of them is just in reverse. I want to think about converting radians into degrees. But also a little more than that. So, a couple things. First, I'd like to address an old issue about the quadrants. I want you to, so it's not related to this, but it is tangential. I want you to think about back in probably Algebra 1, you learned that there are 4 different sections of the coordinate plane, and they're often numbered with Roman numerals in this way. And this is called Quadrant 1, and Quadrant 2, Quadrant 3, and Quadrant 4. And here's just a little fun fact. You might have wondered, maybe you did, maybe you didn't, why order it in this way? Why make that 1? Now 1 makes sense, because that's where the x values are positive, the y values are positive. It just feels like that's the most natural place to label the first quadrant. But why make that one the second one? Why not make that one the second one? The answer is actually because of unit circle trig. It's because of the rotation. It's because when you rotate in the positive direction, you rotate this way. First quadrant should go into second, third, fourth. That's the reason why the quadrants are numbered that way. So hopefully that helps actually you do 2 things. One is memorize the quadrant numbers. You're going to need them. And secondly, understand how it all kind of fits together. It's all about trig. Okay, so that was a little side thing. I do want to, though, think about this question. This is a standard problem that I want you to be able to do better than a lot of students do. Use a different method, a better method. So the standard problem is convert 2 degrees each of the following. Theta equals, 3 pi over 4, let's say, radians. And 2 theta is equal to, 5 pi over 3 radians. And 3 theta is equal to 7 pi. Let's do negative 7 pi radians. Okay, so the standard way that most students get the answers to these when they're young math students is a bad way. It's actually a way that works against you in the long run. The bad way to do this, and if you're doing it, it's not your fault, don't feel bad about it, but take my advice, change this. The bad way is to use a conversion factor. The bad way is to say, oh, anytime I've got radians, I just need to multiply by degrees over radians, so the radians cancel, and I get degrees, and so I'll multiply by 180 degrees over pi in all of these. And these just become really annoying fraction problems. So I do the first one, 180 over pi, pi's cancel. I end up with 3/4 times 180. It ends up, when you do it, it ends up being 135 degrees in greater number. So 3 pi over 4 radians is 135 degrees. You do it over here, you get, gee, can I do this? 300, I think is what you get. Yeah, that's right. Again, you probably have to use a calculator to do this. Fine. But on this one, if you do this, okay, so now I got to think about this one. This one's negative 1080 plus 180 is negative 1260. I think it's negative 1260. All right, I hope that's right. Is 7 times 7, is that right? 700, yeah, it is, negative 1260. Okay. It's a lot of mental math. I set myself up for it. I didn't get the answers first. Okay, so that's a way to do this. It's not the right way. It's not the best way. A better way to get these answers is to think about these almost physically as turns. Think about the geometry. Think about the unit circle. This is the key to most of trigonometry, actually, is always, when you have the opportunity, think of the unit circle. So I'm going to think about, in problem number 1, theta equals 3 pi over 4. I'm actually going to sketch it and think about where it is. Now, 3 pi over 4. how do you sketch 3 pi over 4? Now, most young math students say, well, to sketch it, I'm first going to have to change it into degrees anyway, aren't I? Because I only understand how to sketch things when I'm in degrees. Get past that. I want you to set as a goal that you sketch this without changing it to degrees first. What is pi? I know the answer is 3.14, blah, blah, blah. Who cares? The answer to the question of what is pi in trig, it's a half term. 3/4 of pi, that's what this means. 3 pi over 4 means 3/4 of pi. 3/4 is less than 1. It means 3/4 of a half term. Do you see it? This is such an important idea. I haven't done anything with degrees there. I've just sketched the angle without doing anything, just looking at the radian measure. This is a goal you should have. You'll be so much better at the things that you do in trig if you can set that as a goal and achieve it. And I'll be frank, many math teachers don't tell you that at the beginning. They allow you to do stuff like this, and then when you struggle later on, they're like, well, why didn't you figure out to do this? Because they didn't tell you. I'm telling you. Learn to do it. And now we can get the degree measure by actually just thinking about fractions. 3/4 of pi means literally 3/4 of a half term. Divide this thing into quarters in degrees. 180 degrees. If you divide it into quarters, how much is each? Well, half is 90. So half of that is 45. It's 3 45-degree terms. 45 is 1. 90 is 2. 135, if you can do the mental math, that's what it is. And that's why it's 135 degrees. It's a better way to think about it. Second one, we have theta equals 5 pi over 3. I want you to think about 5 pi over 3 physically. What is pi? The answer is a half term. What's 5/3 as a fraction? Now, I'm not a big fan of mixed numbers. They don't work very well in math. But actually, they work pretty well in trig. Think about 5/3 as a mixed number. Do you see what it is? It's 1 and 2/3. Because 5/3 is really 3/3 and another 2/3. So it's 1 half term and 2/3 of another half term. Do you see it's a fourth quadrant angle? If you don't, work on it. I'm not going to belabor the point here, but you think about this and it's going to be so helpful. 5 pi over 3 is really, that's 3 pi over 3 to there, because it's a full half term, and then 2/3 more gets us into the fourth quadrant. That's what it is. And now numerically, I can get this answer of 300 by actually just thinking about dividing pi into thirds. Like pi over 3, what's pi over 3? Well, there's two answers to that. Pi over 3 is a third of a term, third of a half term. But numerically, as a degree measure, it's 1/3 of 180. 1/3 of 180 is 60 degrees. This is 5 60-degree terms. And 5 times 60 is 300. And that's why that is 300. You see it? A second way to think about it that you can set as a goal, here's a second way, it's a really good way. 5 pi over 3 is just 1 pi over 3 short of 6 pi over 3. Isn't it? It's 1 pi over 3 less than a full 6 pi over 3. Now I say 6 pi over 3 because what is 6 pi over 3? Well, 6 over 3 is 2. So it's 1 pi over 3 short of 2 pi. 2 pi is 2 half terms, which means it's a full, I did it the wrong way. It's a full term. It's 360 degrees. So it's 1 pi over 3 short of that, and we just said pi over 3 is 60 degrees, so it's 360 minus 60. That's another reason it's 30 degrees. Now, if you're having trouble thinking in these ways, I'm not trying to shame you, and I'm not trying to say that if you don't understand these, you're sunk. What I am saying is, go back through this video, keep thinking about these, get the answers in these geometric ways. This is geometry, actually, in a way. This isn't, but these ways of thinking are. And if you're not thinking about it geometrically and fractionally in terms of terms, you're setting yourself back for later. Trig's going to get hard if you don't get good at that. So work on it in these. The last one, negative 7 pi, I'll go more quickly on this. This one's tricky, but it's not that bad. I can definitely sketch it. Negative means go this way. 1 pi is a half turn. So here's 1 pi, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them. There is negative 7 pi. I know you can't see all the loops, but hopefully you can tell from the top part of it. That's the diagram for negative 7 pi. Now changing it in degree measure is, okay, fine, I'll do it. I guess that's 1 360, 720, plus, I think I got 1260 wrong here. Did I do this right? 1, 2, no, it's 3 full ones. 3 times 360 is 1080, plus another 180 is 1260. It's negative. It's negative 1260. I don't think that you should set it as a goal that you can do that mental math to get that number. What you should set it as a goal is if you have to sketch negative 7 pi as an angle, don't change it to degree measure first. Learn to think geometrically in radians. Learn to sketch each of these angles without changing them into these. It will set you forward in your study of trig, farther than you think. Good luck.